Hello everyone, I am Tilman Hartwig, co-developer of A-SLOTH, and in this series of videos I would like to guide you through our tutorials. So to show you how you can download A-SLOTH and how you can use A-SLOTH to do science. So when you're watching this video, you probably already found our Git repository. If not, the link is in the description. This is where we host the code and all the files and documentation. If you scroll down, you find the README file, where we also provide a quick start guide. However, we would recommend to use our documentation page here, that is also linked, and then you can click on Getting Started. So at the beginning, all you need is a terminal. And the very simple method to get the code A-SLOTH is to git clone it to your machine, and that was already how you get the code. There is no installation process of A-SLOTH. However, there are a few system requirements and dependencies. So make sure you have a Fortran compiler and Python installed. There are also some Python packages necessary. They are fairly standard, so maybe you have them already. The code in the version, how it is on the main Git branch, is not very resource demanding, so a normal laptop with a few gigabytes of free RAM is sufficient. We also provide debugging information. So if you encounter any problems at any point, have a look at our debugging page where we discuss and solve some known issues and provide further contact information if you have problems. Once we are set up, we can start with the first tutorial. The tutorials are intended for when you freshly obtained the code. If you have already worked with A-SLOTH and now want to do the tutorials, you might need to get the code back to the previous version, or otherwise some tutorials might be confused, or the Python script might not work as intended. So let's start with tutorial number 1, Hello A-SLOTH. So let's go into this directory A-SLOTH, and we have a make file. So in principle, you can just type make, and it will compile the code with all the correct dependencies. Next, to run the code, you just have to type asloth.exe with the parameter file. So we also provide a parameter template, and that will run the code. So while it is running, we can just see what is happening. So first, this will be important later, we created an output folder with the current date and time. And in this version on the main branch, we use the EPS mode. So we generate merger trees based on the extended Breshrechter formalism. And so here we can specify the halo mass at redshift 0, which roughly corresponds to a Milky Way-like galaxy. Then we generate the merger tree. And finally, you're presented with the parameters for this run. So these parameters are set in param template. So this is what we already did for you. Here they are just presented to confirm. In principle, and in later tutorials, you can change these parameters and then confirm that A-SLOTH uses these new parameters. And then A-SLOTH is running iteratively from high redshift to low redshift, and we are done. So this brought you already through here in the tutorial, and now we can have a look at the results. So we also provide Python scripts. Please note the Python scripts are written in Python 3. So make sure that you use Python 3, which might be standard on your platform. And what this is doing is it will take the latest output folder, which is the one that we just generated here, and it will plot the data from there and compare to 2 other data that we already provided. The reason becomes clear in 1 second. And then it will also tell you a few lines below, plots will be saved in this folder. All the other information you can have a look, you can try to understand. It's not very relevant for the tutorial, and you get some quantification how good the run was, but let's look into this folder. And here we have some plots that we just produced. So for example, we can look at the metallicity distribution function, MDF. And wait a bit. Depending on your platform, you can also download the plots to your computer or just open them if you run it on your laptop. And here we see how this could look like. So here in blue, this is our last run that we just ran. And then we compare to two other runs because A-SLOTH contains random sampling of stars. And so there is a little fluctuation depending on the random seed. And so as long as your model on your computer looks either like the blue line or the orange line or the green line, everything is fine. And there are 3 other models from the literature to compare to. There are other figures that you could check, but for this tutorial, I think it's enough to check the Milky Way, MDF, and we will continue in tutorial number 2. Thank you.